In this video, we're going to discuss the solutions for the midterm exam in statistics. It is going to have two parts. The first part contains 13 questions, which is necessary to answer shortly with a brief explanations, and the second part contains 4 problems with the complete solutions. So in the first question, we need to find the class widths, the midpoint of the first class, and the class boundaries of this two classes in the frequency distribution table. In order to find the class widths, we need to subtract the 2 lower class limits or 2 upper class limits. It is going to be equal to the 5. The class midpoint is going to be the middle point of this class. It is going to be 1 plus 5 over 2, which is equal to the 3. And in order to find the middle point between the two classes, it's going to be 5.5. We need to look to the upper class limit for the first class and lower class limit for the second class. So if you're given the data which contains the weights and the year of manufacturing for each of the 22 pennies, we're going to use the scatter plot. At the same time, it is okay to use the time series plot for this type of the data. So if we're given the data, so in order to create a steam plot, we need to split every data point into the 2 parts. Basically, in this case, it's going to be 9, it's like a tens, and 5, 3, 3, 1. So this is going to be the steam plot for this data. So in the following problem, we're given the 5 numbers. We need to find the mean, median, and the mode for this data. In order to do this, first of all, it is necessary to sort all the data points. So if we write them in order, it's going to be 2, 2, 3, 4, 9. So in order to find the mean, we need to add all the 5 numbers. It's going to be 2 plus 2 plus 3 plus 4 plus 9 divided to the 5. So this is going to be equal to the 4 since the sum is equal to the 20. So 20 divided to the 5 is equal to the 4. The median is the number which is going to be in the middle when we sort the data points. It is going to be 3. And the mode is the most frequent data point, which is 2. So the 2 is most frequent in our set. So the question number 5 is about the probability. So if the probability of the A is equal to the 0.7, then the probability of the A prime, which is the complement of the A, is equal to the 0.3, since we know that the probability of the A plus the probability of its complement should be equal to the 1. So if the data set has the mean, which is equal to the 5, and the standard deviation, which is equal to the 2.5, we need to find the corresponding z-score using the formula, which is x minus mu divided to the sigma, which is equal to the 7.5, which is the x, minus the mu, which is the 5, divided to the sigma, which is 2.5, which is going to be equal to the 1. So a standard deck of cards contains 52 cards. So we are required to find what is the probability. If we choose one card, this is going to be the king. So probability of choosing a king is equal to the number of the kings in a standard deck divided to the number of the cards, which is going to be 1 over 13. So in the second problem, it is going to be the conditional probability. So basically, if you're given this kind of vertical line, it means that this event has already happened. So you choose the card and you know this is the red card already. And we need to find the probability that this card is the king, right? Probability that the card is a king if you have already choose the red card, it is going to be. So now we're going to count how many red kings we have. There are 2 red kings and there are 26 red suited cards. It is going to be 1 over 13 again. Question number 8 is about the number of arrangements of the letters in this word. So there are 1, 2, 3, 4, 5, 6, 7 letters, right? So if all of them would be different, then it would be 7 factorials. So since I've got the 2 R's, which are the same, I need to divide this to the 2 factorials. If you consider this capital A and a small a are different letters. If you consider them as equal, then you have to divide this to the 2 factorials additionally. So both of the answers are going to be considered as correct. So the university assigns the students the ID numbers, which contains 2 letters of alphabet followed by the 3 digits and we cannot use the same letter and the same digit twice. So in order to find the number of the ID cards which can be generated, we need to make the boxes. So 5 boxes. So we can use only the letters for the 2. It means that I can use any of the 26 letters for the first position. Since I used one of them, I cannot use this, so it's going to be 25 options for the second option. So one of the 10 digits can be used here. Since you use one of them to here, you cannot use this, so there are 9 options for the second and 8 options for the third one. So the option which corresponds to this answer is D, since the 26 factorials divided to the 24 factorials is exactly equal to the 26 multiplied to the 25. So the Medas pharmaceutical company receives a large shipment of aspirin tablets and randomly selects and tests 40 tablets. A probability that each tablet is rejected is 1/40. Then the number of the rejected tablets is going to be a random variable, which is going to follow the binomial distribution, right? So if you have the 40 tablets, so if you test all of them, probability, so the number of the tablets which are going to be bad, it's a random variable, so it is going to be different every time, but we know that it's going to follow the binomial distribution because this experiment actually is a binomial experiment. So problem number 11, if the 2 events are mutually exclusive, then which of the followings are true for this? So we are talking about the mutually exclusive when we talk about the probability of the A or B, or additional rule we call this, and this is equal to the probability of the A plus the probability of the B minus the probability of the A and B. When the 2 events are mutually exclusive, then this is equal to the 0, and the probability of the A or B is equal to simply probability of the A plus the probability of the B. So in this question, there are 2 correct answers. Either you can answer as a C or as a D. So the systematic sampling is about this answer B. We select some starting point and then select every case. All the others are going to be non-systematic sampling. So question number 13 requires you to explain the solution for this question as well. So without the solution, this question will not be graded. So the last 5 questions in this section are multiple choice questions, including this one. If you guess at random for every question, so the probability that you will get the correct answer is going to be 1/4 because there are 4 options, and probability that you're going to be wrong is 3/4. In general, I've got the 5 questions, n is equal to the 5, and I need to find the probability that you're going to answer at least 1 question correctly. Basically, x, which is the number of the correct questions, answered questions, is going to be a random variable which is going to follow the binomial distribution when the probability of success is equal to 1/4, when the number of the trials is equal to the 5. So in order to find the probability that x is at least 1, which is more or equal to the 1, so you need to find the probability of x is equal to the 1, 2, 3, 4, and 5 and add them. Or what you can do is you can subtract this from the probability of the x is equal to the 0. Since if you put this term to the left, it is going to be the sum of probabilities for all possible values of the random variable x. So probability of x is equal to the 0, it means that you answered all the questions wrongly, right? Which is q multiplied to the q multiplied to the q multiplied to the q multiplied to the q, or basically 5 times q, which is going to be 3/4 in the power of 5, which is going to be roughly 0.2373, and the probability that x is more or equal than 1, it's going to be 1 minus this number, which is equal to roughly 0.762. So the correct answer is A. So please note that the complete solutions are required to get the credits for this question. So part 2 contains 4 problems. So let's start from the first one. If we are given the frequency table, we can find the mean, the average of the data points, roughly, approximately, because so the frequency table tells me that there are 3 data points which are in the between 0 and 3, but we don't know what are they exactly. What we're going to do is we are going to say that, hey, they are approximately equal to the 1.5, which is the middle point of this class. And we're going to multiply this to the 3 because there are 3 numbers in between these two intervals. So plus 5.5 multiplied to the 7 plus 9.5 multiplied to the 8 plus 13.5 multiplied to the 5 plus 17.5 multiplied to the 2, right? This is going to be the sum of all the entries of the data set, and we have to divide this to the number of the data numbers. It's going to be 3 plus 7 plus 8 plus 5 plus 2, which is going to be roughly 8.86. So in the second part of this question, we're required to draw the histogram. So in order to do this, we are going to just draw the bars for all the classes. It's going to be, I've got the classes between 0 and 3, 4 and 7, 8 and 11, 12 and 15, 16 and 19. So now we need to draw the height of the classes correspondingly. The height of the first class is equal to the 3. The height of the second one is 7. The height of the third one is 8. The height of the fourth class is equal to the 5. And the height of the last class is equal to the 2. So it is necessary to indicate the heights as well here. So it is best 3. Problem number 2 is we're given 11 data points. We are required to do the following steps. So in the first step, we just need to sort them. So if you sort them, then we're going to write them 12, 14, 19, 20, 21, 28, 29, 30, 55, 63, 63. On the step number 2, we need to find the mean. Basically, we're going to add all of these numbers and so on until 63. And we're going to divide this to the number of the numbers, which is equal to the 11. So the sum of all of these numbers is equal to 354. And if you divide this to the 11, we obtain 32.18, or you can roughly write this as 32.2. On the next step, what we're going to do is we need to find the standard deviation. So the standard deviation can be found by summing all the numbers. So taking the difference between all the numbers and the mean, which we find previously here, taking the square of them, and by summing them and dividing them to the n-1, we have to take the square root of this. So this is going to be the standard deviation. So basically, I will going to show you for the first data point, it's going to be 12 minus 32.2 in the square, right? Plus 14 minus 32.2 in the square, plus 19 minus 32.2 in the square, and so on, plus 63 minus 32.2 in the square, and we have to divide everything to the 10 and then take the square root. So that the answer is going to be equal to the 19.0726. In the question number 4, in the D part of this question, we need to find the Q1, Q2, Q3, which are going to be the median. So Q2 is the median of this data set. Median is the point which is in the middle, right? We need to count the 1, 2, 3, 4, 5, 6. So this is going to be the median of this data set, which is the Q2. So the median of the first part is going to be the middle of this 7, 8, 9, 10, 11. So the median of this part is going to be this number, right? Q1. And the median of this part is going to be this number, Q3. So the Q1 is equal to the 19, Q2 is equal to the 28, Q3 is equal to the 55. And in the last part, we need to draw the box plot, which we're given. In order to do this, we need to first of all draw the point which is on the 19. Then we need to draw the Q2, which is going to be 28, which is going to be roughly here, and 55, which is going to be here. And additionally, that's really important, we need to put the minimum point here. So the minimum point in our data set is equal to the 12, and the maximum point is 63. So we need to indicate those numbers as well. So we need to put here 12 and 63. Then we need to connect this with this. It's going to be the box plot for our data set. Problem number 3, it's about the normal distribution. So we are given some data. So the average grade of a large population of the university students follow the normal distribution with the mean 2.2, with the standard deviation 0.6, and with the so what we are going to do is, if you choose one of the students' grade, what is the probability that this grade is going to be more than 2.91? So basically, if you choose one of the students' grade, it is going to be a random value, right? And this random value follows the normal distribution with the mean 2.2 and the standard deviation 0.6. What we need to do is we need to find the probability that this x is more than 2.91. So in order to find this probability, what we're going to do is we're going to subtract the mu from the x and divide this as a sigma. So this should be more or equal than 2.91 minus the mu divided as a sigma. In our case, the mu is 2.2 divided as a sigma. So the reason why we're doing is that this value, x minus mu divided as a sigma, is the z, the standard normal distribution or standard normal variable. It should be more or equal than this value, which is roughly 1.18, right? So we need to find its value using the cumulative distribution. So here is we are given the table. So basically, so if you put this, so for the standard normal distribution, this value is 1.18. We need to find the probability that the z is more than this, right? Basically, we need to find this area. While this table is going to give us the area until this point, which is measured from here, right? So first of all, let's find this area, the cumulative area until this point. So I need to find 1.1 and 0.8, which is going to be 0.881. So this area is going to be 0.881. So correspondingly, this area is going to be 1 minus this area, 0.881, which is roughly equal to 0.11 right? So the probability that if we choose one student's grade, it is going to be more than 2.91 is going to be 0.119. Question number 4 is about the probability distribution tables. If we're given such a table, we would like to find the expected value, the variance, and the expected value of the x plus multiplied as x plus 1. So the expected value is found by multiplying every number to its probability, and we have to sum this at the end. So 5 multiplied to the 0.1 plus 2 multiplied to the 0.1 plus 3 multiplied to the 0.3 plus 1 multiplied to the 0.3 plus 4 multiplied to the 0.2. So if we sum this, it is going to be 0.5 plus 0.2 plus 0.9 plus 0.3 plus 0.8, which is going to be equal to the 2.7. So the variance of this random variable is found using the formula e of x squared minus e of x in the square. So please note that we can find the expected value of the new variable x squared by squaring the values of the x and by multiplying this to the same probability. So basically 5 in the square multiplied to the probability of the x. It's going to be 5 in the square multiplied to the 0.1 plus 2 in the square multiplied to the 0.1 plus 3 in the square multiplied to the 0.3 plus 1 in the square multiplied to the 0.3 plus 4 in the square multiplied to the 0.2. So let's calculate this. It is going to be 2.5 plus 0.4 plus it is 9 multiplied to the 0.3, which is 2.7 plus 0.3 plus, so 16 multiplied to the 0.2 is going to be equal to 3.2. So if we add everything, we are going to obtain 9.1, I guess. So the variance is going to be equal here, 9.1 minus 2.7 in the square, which is equal to 1.81. And in the last part, we need to find the expected value of the x multiplied to the x plus 1, which is going to be equal to the expected value of, I can open the brackets, it's going to be x squared plus x. So please note that you can write this as the expected value of the x squared plus the expected value of the x. So since we know this and this, we can easily find this. It is going to be 9.1 plus 2.7, which is equal to the 11.8. So the answer for the last part is equal to the 11.8.